everyone. This time we come back to not come back, come forward to a new session. Uh, After we discuss about the formulas of derivative, uh, now we go to integration formula. Before we go to integration formula, I want to make up one missing part of the derivative formula, which is here that I'm showing here. That is derivative for square root of a squared minus x squared. A here is unknown number, okay, unknown number, okay. So it's equals to anyway. If just by common sense you will never draw such a solution, right? By common sense only speaking. So, but this is a real and this is the right formula. And I'm wondering, do you still remember what arcsine it is, right? What is arcsine? So if you forget, you have to check my previous session. So this is, I think, is quite important. I'm missing formula for derivative. So the square root of a squared minus x squared is derivative is equal to 1/2 x times square root a squared minus x squared plus a squared over 2 times arcsine x over a plus c. Okay, so I will not have take more time before this time, because this time we'll focus on the integration, not the derivative. So first, the formula number one is a constant times a fx function, then df dx. This integral, we can draw the constant come out, only integration for the fx part. So what's that mean? If give example, this f3, and then this is x squared plus 1 dx, right? So fx is equals to what? X squared plus 1. So we can equals to take it 3 out. So x squared plus 1. Then let me move right side down. Please expect this will, if I give explanation and demonstration, many will move very right side. Okay. Okay, so the second one is integration. Let me write here. If exponential, remember, this is different from below. This here, the x on the x is at the base, and below x is at exponential. So exponential function, this one is not exponential function, okay, just x to the nth power. And this one equals to 1 over n plus 1, then x to the n plus 1's power plus c. Now remember, for all the integration formulas, they all have a plus c, because you think about the opposite way. If it is by this one right side derivative, the c will become 0. All constant derivative is 0. So, right? That's why they will disappear. So this c can be 0 as well. Yeah, just depends on the real scenario, right? So this one, for this formula, we can give example like easy to understand. So if this is will be x plus 1 to the nth power, to the 5th power, okay, dx. So it will be equals to what? N plus 1, 6, right? Then x plus 1 to the 6th power. Am I right? So this is the final answer. Okay, so next one is to the e to the x power. Remember, for derivative, if e to the x power, the exponential function, the derivative is itself, right? So that's why the opposite way also the same, but here plus c. Okay, so I don't necessarily need to give any example, because here no seems no need. Okay, but the only example is that you can make x as x plus 1, x squared plus 1, whatever, right? Okay, so Next one is integration of 1 over x is equals to natural logarithm to the x plus c. So let's just simply think about that. The derivative, right, is equals to, if derivative is equal to 1 over x. So this is just the opposite, right? Just opposite operation, reverse. Then we go to this also same, sine cosine second. Sine x dx integration is equal negative cosine x plus c. The only thing is here O plus c. You just think about negative cosine x derivative is what? Is sine x. So here, right? Same here, cosine derivative is sine. And the second derivative, second square derivative is tangent x, right? So how about this one? Integration of 1 over, wait, let me check in how many integration formula to introduce. This is number 3, this is number 4, this is number 5, this is number 6, this is number 7, this is number 8, this is number 9, this is number 10. Okay, so 1 over x, 1 plus 1 over 1 plus x squared dx is equal to arctangent x plus c. So better remember those kind of things, especially when you always need to do exercise, this kind of computation. If you don't necessarily need this, always need to use this, then you might not necessarily to remember, but you have to spend a very long time to prove that. Okay. So next one, number 9, is integration to the a. We already talked about what is a, it's unknown number, right? A to the x power dx. This is exactly exponential, right? Exponential function, right? When the x is to the exponential part, right? Power part, not at the base part. The base part is null. So it's equals to a to the x power divided by log natural logarithm of a plus c. Okay, I will not prove this one. It might be very hard for me as well. So, but we'll spend long time for this. Okay, so if you're interested, you can see some kind of resource on YouTube or anywhere otherwhere, so you can find the solution about this. Then the list one I also feel very interesting and also hard to believe. But anyway, it is integration of log base a to the x dx equals to 1 over natural log a times 1 over x plus c. Okay, just remember. And then number 11 and number 12 and number 13. In fact, I have number totally 16, I think. Yeah, so number 14, 15, 16. Yeah, I'm right. Okay, so let's come here. So definitely we already know arcsine derivative is 1 over square root of 1 minus x squared, right? So this is just the opposite operation. Same as here, arc second also the same. Just remember, it will make you remember here, because when we do integration, many integration function, or just doing integration of the fx, we many times face like this kind of thing, this like thing. We really don't know, have no idea of how to solve that. And if we know, it will spend very long time. But if you remember this, then it will be just to make it in second. And formula 13 is interesting. It's just there's anything change is b and a, right? But here, if you change the b and a to their position, you have to add the x, right? Imagine that it makes sense, right? It makes sense, right? It makes sense, right? Because it start from a, then come to be, right? Differentiation in this area, right? This integration, in fact, can be imagined as a calculating of the area, right? Area, right? Of something in the graph or something area, even can be area of what? Of square or um, rectangle, right? So definitely, if you change their position B to A to B, you change of the sign, right? The positive, negative, right? So they just plus a negative, right? So so just let's give a short example. If this is 2, 4, and then this is what? X. Most easy one, okay, dx. So this will be what? This will be, first we derivative them, okay? We first integrate them. So this will be this one, right? And we need to prove it will be equals to what? Negative y, 1/2 x squared and 2 to 4. Is that same? Let's see the first one, first one here. Then it's 1/2 is always there, and then 4 square minus 2 square. Am I right? And then let's see the second one is what? Negative 1/2, and then 2 square minus 4 square. Definitely they're same, just to change the sign, right? So that's right? Then this one, if you think about this one, it's very easy to understand. Imagine this is an area, right? Since this area, you either can think about this AA as the length increasing, or either you can think about is a width in the area, right? You better think about, since they don't have any increasing, so of course the area is 0. Am I right? Makes sense, right? Okay, and number 15 is it's very funny. In fact, I'm not so uh, I definitely know this, but we don't have many. If you want to prove this, it's not very easy. It's hard, but I want to let you know. But for common sense, you can accept this concept, right? As when it's BA, right? When it's BA, you can separate this integration in this part and find the number in between C. So you can calculate in the C from C to A integration and the plus, then from the upper part B to C, right? If you want to prove it's also easy, we can make like here the same here, like here, right? We can make it and 3 to 2 and 4 to 3. I think definitely we can get the same answer. If you don't believe, just try. 16 is the most important part I want to introduce to you. I also will provide a short example. Anyway, before this, I want to give a short summarize. So based on this, we already find that soft integration of fx, it's very hard, right? It's very hard. Sometimes we spend very long time, especially when you learn the 16. 16 is called partial integration. Why it's called partial? Because it's integrate by part. Just yeah, it's like this way. So suppose u is the function of x, v is another function of x. If they are together, times together and integration. So we will how to solve this? We will what? We will integration by part. Okay. So first, this is formula. Okay. So this is u take out, and then integration v dx minus what? Integration what? Derivative of u times what? Integration of v and then integration them together. It looks very complicated, right? And I think the one definitely who find this one, I don't know exactly, that definitely is a great mathematician. Okay, so let's just give a simple example to see how this is used and how we can make it so simple. So just example is like this way: x, not cosine, x minus 1. It's okay, right? X minus 1, then no, sine x dx, right? So here, what's u? In fact, your which one is u, which one is v, it's up to you. Okay, okay, not just because it's in front. Okay, because we think about the for multiplication, there's no, these two numbers can exchange, right? So we just make it easy. U equals to x minus 1, while v equals to sine x. They're all the fx of x, right? So based on this formula, how to solve this one? First, u, so x minus 1, times integration of v. In science x integrate is what? I remember is negative cosine. Let's just remember, okay? Yeah, negative cosine. Yes. Sorry, I cannot say I'm good memory, so I have to check. Anyway, I will omit all the c first, but finally I will add a c, okay? Because the c, if you always put here, it will be very confusion, okay? So here it will be negative cosine x. So the first part done, huh? How about second part? Second part is all together inside, right? So mu u prime. So x minus 1 prime is 1, all right? And the times what? Integration of dx. Integration of dx we already here, right? A negative cosine. So here is what? Negative cosine what? Cosine what? Cosine what? Cosine x, of course. Then dx, right? So here is like a anyway. Okay, just simplify. Okay. If we want to simplify, I think this way much better. And we're writing as cosine x minus what? X cosine x minus what? So negative can put in front, become positive, right? It's okay, right? So cosine is sine, right? Sine x, right? The integration is sine x. So sine x, and this will be plus sine. So this is the final answer. So think about that. If we don't know this formula of partial integration, this one is very hard. Yeah, it's very hard to solve. Speaking is very hard to solve. Yes, okay. So thank you very much. I spent almost 20 minutes to introduce this session of all the formulas of I think I introduced the majority of the formula, not all, of the integration. Hope you really learned something. Of course, the example I give are very simple. I maybe have another session regarding the formula integration, but definitely will make little hard, and definitely will spend more time for that. But I will just give one or two example. Okay. So thank you very much to learning together with me. Thank you, and have a nice day. Bye bye.